So today we're going to start our unit on computer science and software engineering. So some of you, when we first started the course, talked about how you may have struggled with computer science, or you kind of forgot a lot of the things that you learned there. But my goal in this class, as we learn computer science and hopefully get to apply it to robots, is to make it so that you internalize the concepts of computer science. Maybe you're not able to deal with all the syntax of Java or NetLogo or whatever it was you learned, language you learned in your class, but you can go through the logic of using loops, using conditionals, and really seeing how they apply to actual moving robots. So today we're going to learn about flowcharts. So I posted a video clip from the show Big Bang Theory, which I am personally a fan of. And I want you guys to pause the video here and just watch it really quickly, because it kind of goes in to what a flowchart is and how it's used. So pause and then resume once you're done. Okay, so a flowchart is basically a representation, a drawing that shows how a program or process works. So let me write out the definition of a flowchart for you guys. So flowchart, it's a schematic representation of an algorithm or a process. So a flowchart has many different parts. The first part is what we call start/end. And the way a flowchart works is there are all these parts have their own shape, and whatever is written in it, based on the shape of what is written inside of it, you know what it is. So the shape for start/end is like this. And that'll always be at the start and end of your flowchart. So shape is rounded rectangle. Start is required for all flowcharts. Some flowcharts have no end. They just go on forever. The next part of a flowchart is what we call process. And process is just a rectangle. Rectangle. Process involves the action or verb part of the flowchart. So let's say I was making a flowchart that I would use to instruct someone to create a peanut butter and jelly sandwich. Well, something I might put in there would be spread peanut butter onto bread, something like that. Some examples outside of peanut butter and jelly sandwiches is, add one. So here are some examples. Add one, turn motor on, turn light off, spread peanut butter. Okay, that's process. The next one is input/output. Underline these. Input/output. This is a parallelogram, like that. Shape is a parallelogram. Hope I spelled that right. I think I did. It indicates that some sort of manual operation is needed. So if you're using something that is calculating something, like let's say you're calculating your BMI. I don't know if you guys still do that in gym class where it compares your height to your weight. But let's say you were calculating your BMI and you had a program that was doing that. You might have something that types in your weight, asks you to type in weight or type in your height. Let's say you had a function that did some sort of calculation and there were variables in there. You might have type in your X value, type in your Y value, stuff like that. So this is where a person can input stuff into a program. So here's some, so it indicates that manual operation is needed. Examples. Type in weight. Check balance. Like in a bank account, check balance. Time in the operation. That's input output. Next part is decision. This is shaped like a rhombus. So this is going to be yes or no. It's like a Boolean, which is something you probably, hopefully remember from your CS classes. Outcome is either yes or no. It's a Boolean value. So some examples. Is the number larger than 10? It's always going to be a question. Does the weight meet specs? So stuff like that. So in the context of a peanut butter and jelly sandwich, it might be, is there peanut butter left in the jar? Is there still, have you totally spread peanut butter all over the bread, or is there still space left for more peanut butter? Okay, the next part. Arrows. So a flow chart. There's a flow. There's you're going through a process. Arrows indicate that flow. So where you go from one step to another. Sometimes it doesn't just go straight down. Sometimes you loop back to a certain part of your chart. So arrows indicate the flow of the chart. Arrows go from the output of one block, so one of the blocks we've mentioned before, the start end, the process, the input output, the decision. Arrows go from the output of one block to the input of another. This is an important note, only one arrow can represent outputs, but multiple can represent inputs. And as we do some of these, that'll start to click why that's the case. Okay. So that's all the parts. Just to review, we have our start end, our process, our input output, our decision, and our arrows. Now, flowcharts are very useful for laying out how a program will work. We oftentimes will start with a flowchart before we write any programs just to go through how things should perform. This is especially true when it comes to robots. You know, in your software classes, in your computer science classes, it's oftentimes theoretical. Maybe you're making a game and you're talking through what things might happen, and you're making flowcharts or pseudocode. But with robots, it's especially important to talk through flowcharts of how things are going to work. When we program our robots in this class, hopefully we'll get the chance to make them and program them. There's an autonomous portion where the robot just works on its own, and you need to walk through every single process, every single decision that's being made by your robot. Maybe your robot's using a sensor and checking, using a decision. Maybe your robot's using a process. You're saying turn on a motor, stop a motor. Turn on a motor, is the sensor reached a certain value? Stop the motor. So this is the way flowcharts work in terms of our robots. Flowcharts are also sometimes really used in the code. There are several code types that actually work with flowcharts. LabVIEW is a common one that works off of flowcharts. So it's really easy to use because if you just understand flowcharts, well, you understand all flowchart programs. Okay, so let's do a sample flowchart. I want you guys to make a flowchart that counts from 1 to 9 by odd numbers. So problem 1. Before attempting to draw this flowchart, determine what you want the output to be. And as a reminder, what's that first block going to be? It's going to be our start end. So create your flowchart, pause the video here, and then when you resume, I'll show you the answer. Okay, so the first thing we're going to have, and there's a couple of correct ways to do this. First thing we're going to have is we're going to have our start. And all we need to do there is we just write start. Then from there, there's going to be some sort of, you could have an input from the user. You could just start at 1 also, but I think it makes sense that this program would work for more than just 1, but going from any start point. So input 1, the user inputs 1. Then it's going to say the number. It's going to do an action, a decision, not a decision, a process. So say, I'm going to put a pound sign, a hashtag for number. Say number. Then we're going to, again, another process, add 2. So it takes that number and adds 2. So we were at 1, now we're at 3. And then it's going to do a decision. Is the number greater than 9? If the answer is yes, we end. If the answer is no, we loop back to here. Now let's try this out and make sure it works. Input 1, say the number, 1. Add 2, we're at 3. Is it greater than 9? Nope. Go back, say the number, 3. Add 2, we're at 5. Is it greater than 9? Nope. Say the number, 5. Add 2, we're at 7. Nope. Say the number, 7. Add 2, say the number, 9. 9, greater than 9.